Okay, so I'm going to start encoding some instructions for shifting packed data left and right. So here we have PSLL, PSRA, and PSRL. These ones actually have quite a lot of different operand encodings. So down here for the legacy versions of these instructions, we have RM when there's no immediate, and then when there is an immediate, the M operand comes directly before the I operand. For the VEX and EVEX encoded instructions, this means that we have RVM as usual for this sort of form of instruction. But then for when we've got the immediates here, they basically shift down, so reg gets pushed out here and it becomes VMI instead. And then for the case when there's no immediate, it's RVM as you'd usually see in this form. So I don't think I actually have a VMI as an operand encoding, so I'll have to add this. But basically, there's a lot of different operand encodings for all these forms, and then along with that, there's basically different suffixes for different sizes: W for word, D for D word, and Q for quad word. The D word and quad word ones, when there is, I think it's when there's with an immediate. Only when they're with an immediate do they support the broadcast. If they are using the M operand, there is no broadcast here. Or if they're using the M operand as the last operand, there's no broadcast. If the last operand is an I operand, then the M operand does support broadcast for only Q and D. So we'll start by creating some tests for this PSLL instruction, because these will basically copy over to the other instructions as well. So let's go to the encoder assembly. So this is PSLL, and we have W, D, and Q suffixes for these, but we're going to skip the MMX versions. So we'll start with W. So W starting with SSE2 for the legacy encoding has RM. So we'll do xmem0 followed by xmem1, and then we'll change this into a memory access. Then if we continue down, we also have this RI version. So this is basically just going to be register followed by an immediate. Then that is it for the legacy. We'll skip D and Q here, and we'll go straight onto the VEX encodings for W here. So for W here we have, this is basically RVM for this one. So we'll do VEX R V M, so M can be a register, but it can also be a memory access. And then we also have VMI. So VMI is going to have the immediate, but the middle operand can be a memory access as well. Or actually, no, this one's just... this one is only register. So if we go and look at D down here, D is saying VMI, but the M operand in this case isn't actually showing memory here, so we'll actually get rid of this memory access and only do register with the immediate in this case. So skipping down to the next W version. So this is where we get the same thing but with YMM instead. So we'll just make a copy of these ones and change it to YMM. Then we'll skip over the D and Q ones again. So onto EVEX, we now have RVM again. And in this case, it looks like it's RVM, and then for this one, it's supporting XMM and YMM and ZMM. Then if we continue down, there's the immediate versions where they do support a memory access in the second slot there. So if we just do these ones as EVEX, so this is basically EVEX. We've got RVM. So this is RVM for these two. There's no memory broadcast here. Then for the immediate version of this, we have VMI, where the I version can actually support a memory access in this case. And then we need a ZMM version as well. So that's W done. Let's just make sure that NASM is okay with this. So mask is not permitted on this operand for line. So we've got invalid. Okay, so first of all, invalid combination of opcode and operands on line 9. That's this one. So this one is where we're saying YMM for the VEX encoded version. So for the VEX encoded version, we get XMM, then we go up to YMM. This one should be XMM as the final operand here. Okay, let's just assemble again. So the mask is not permitted on line 16. So this one is EVEX, and this is YMM should be with XMM, and the final one in ZMM should also be using XMM. So this should always be XMM here. So let's just assemble that. Okay, so that's correct now. So if we just take these, the D versions of these are all the same, except the EVEX encoding for these actually supports a memory broadcast when using the immediate. So if we just go to this and we'll change SLL to SLLD. Then in the EVEX versions where we've got a memory access and an immediate, we'll just make a copy of these where we do the broadcast. So this will be 1 to 4, then we'll do 1 to 8, and then 1 to 16. That's all okay, and then we've got Q as well. So in this case, because it's Q, the element size is doubled, so the lane width of the broadcasts needs to halve. Okay, so that's PSLL done. We'll then go on to, there is a PSLLDQ as well. So these ones basically have just the immediate versions. So let's just copy this one. And we'll get rid of all of the things that don't have an immediate. So for example, this one is RI, and this is RI. This one is like, this is probably VMI. Yeah, VMI. So we'll just get rid of all the ones that don't have an immediate here, and then check over them. Does this one support broadcast? No, it doesn't. So let's just get rid of these broadcasts as well. Get rid of memory and registers in the final operand. This doesn't actually support opcode masks or op masks either. So for these EVEX versions, we'll just do a high register. And then the second operand for VEX and EVEX can do memory access. So if this is the EVEX one, it looks like VEX can also, VEX can't do it, it's just EVEX. Okay, so that's fine. I think that should be enough tests for that. Let's just change this to DQ. And reassemble. Okay, that looks okay. So the other one that has a DQ version is a PSRL, and this will basically be the same form, so we'll just copy all of these tests and change PSLL into PSRL. Okay. Then the other instruction that we've got here is PSRA, which doesn't have a DQ version, but it looks like it's the same as the other ones. So we'll just take PSRL, make a copy of this, put it below here. And then we'll just update this to be PSRA. Okay, I think that's all of it. Wait, we've got an instruction inspector, PSRAQ, PSRAQ. I would have thought that would be... Oh, there's no legacy version for PSRAQ. Okay, that looks like it's all okay now, so let's just reassemble these and create the listing with the tests. Okay, let's just transform that and then align them all. Reassemble to generate the listing. And now we just need the mnemonics. So let's just take all of these ones. We don't need shuffle, already got shuffle. Okay, so it's just these shift ones. Okay, let's just go and remove all the duplicates. So we'll separate by LL, RL, and RA. Let's just go and put these in the name table. And then we just need to go and put these in the form tables. Okay, so go test should fail immediately as usual. So PSLLW is what we'll start with. So PSLLW, we're going to match on X word first. The op n for this one is RM. Let's just check that. So we've got RM and then we've got MI. But the MI encoding here only actually accepts a register. So op n for this first one will be RM. Let's just recheck the tests here again. Yeah, so we've got RM and then MI. Okay, so this is RM, this is op1 is VEC, and op2 can be VEC or memory. And for this one, we've got a prefix of 66. we have a map of 0f and an opcode of f1. Then we have the other legacy form, which is the immediate version. So this one was mi, where we've got only the vec in op1, even though it's an mi encoding. And then here, this is always an immediate 8. So this one is prefix 66. Map is 0f still, and then it's 7-1, but we've got an opcode extension of 6. Yeah, 7-1 with an opcode extension of 6. So that should take care of the legacy forms. Then we just need the vector forms, so vex and evex, I should say. Family vex. We'll do family vex for this as well. So this is going to match on X word and Y word. So down here we've got X word and we've got Y word here. So for these ones, these are encodings C, and the immediate one is D. They both only accept register in the first 2 operands, so this one being RVM, probably. So C is RVM, and then for VMI, although it's the M operand, it doesn't actually accept memory in this case. So we'll do RVM. This is the one that accepts vec. Then op2 is vec, and then op3 is vec or memory. Then for the VMI, which I don't actually have yet, we've got vec. Op2 is always just vec, and op3 is always an immediate 8. So for these ones, we've got, let's see, 660FF1, and then 7-1 with opcode extension 6, so that's actually the same. So I'll have to add a VMI to the operand encodings. So let's just put this here. This will be VMI. And then we'll just add a case for this. So we've got VMI. V is going to come first. Then we've got M, which is RM, and then we've got reg here, which is actually an immediate, which is going to be taken care of by the loop at the end, so I can probably actually just remove that. Okay, let's just see how that goes. Okay, so now we're on to the evex ones. So the vex ones actually matched and passed. That one's MVR. VMI should get me back to PSLL. So now we just need the evex versions of these. And the evex versions are going to support in the first operand op mask and zeroing. And these are the same encodings, I think. So we've got RVM and we've got VMI for all of these. So yeah, it looks like it's the same encodings. When I get to tuple types, I'll have to split a couple of these out to support full mem and full, even though they're the same operand encodings. The tuple types are different, but for now we'll just ignore that. So the W1 doesn't support broadcast, so it should be enough to just do that. Then the W encoding for evex here It's still 7.1 with the opcode extension 6, and it's still F1, and the W bit is ignored in these cases. So let's just see what's going on here. EVEX for W. This one does actually support memory, which is why we're failing to find something for this memory access one here. So EVEX for VMI, we need to do is, well, let's just see, is it for RVM, do they actually support the memory for that one? So for RVM, we've got, this is E and F. So if we're looking at E here, for example, this one does support memory. So yeah, I think I can just add memory to both of them. This one is at, yeah, okay. I think actually this one only has immediate anyway, doesn't it? So we'll do encoder ASM. Oh no, it doesn't have, okay. Let's just see. We've got the immediate versions here. Yeah, okay, so in this case, RVM op3 does support memory, and then in this one, it supports memory on op2 for VMI. Okay, so we've got VPSLLV, so this is because these need to support Z-word as well. Okay, so now we're on to the LD version. So let's just copy this. Bring this down to LD. Okay, so what's the difference with D? D is basically using F2 as the opcode and 7.2. So these ones, F1 can change to F2, and 7.1 can change to 7.2. So these ones actually support broadcast as well for EVEX in the memory version. So we've got RVM. Does it support broadcast on all of these though? If we've got the EVEX version of D, this one supports only memory here, but then in the immediate cases it supports broadcast. So for the VMI operand encoding, this one should support broadcast. And then it'll be the same thing with Q. So Q here, I'm assuming, just moves up to F3 and 7.3, which looks like it's correct. So we got, we'll just rename this to Q, change F2 here to F3, and change 7.2 here to 7.3. And it looks like EVEX also needs the W bit set. Okay, so now we're on to DQ. So DQ for PSLL. This one has legacy, but it's only the immediates. So I could probably just copy these ones, rename this to DQ. This also doesn't support op masks or broadcast. And we don't need the RVM encoding here, because this is just VMI. And we don't need the RM encoding, because this is just MI. So this one is 7.3 with opcode extension 7. So this is 6, we'll change this to 7. And the W bit is actually ignored for these ones, so we'll remove the W bit. Okay, so now we're on to PSRL. These ones I'm actually just going to copy PSLL and rename it to PSRL. And with PSRL, we've got D1 for the RM encodings, but we stay with 7.1 and opcode extension 2 for the others. So where we've got opcode extension 6, I'll just change all of these to 2 because it's probably going to be the same for all of them. RL does have this DQ version, which is opcode extension 3. And that's 7.3. So we'll just change, we've got D2 instead of F2. So we'll just change these 0xF into 0xD. Okay, so now we're on to PSRA. So PSRA here doesn't have a DQ version, so we'll just copy these ones without the DQ version and put them into here. So PSRA does E and opcode extension 4. So let's change opcode extension 2 into 4. And then instead of 0xD, we'll change it to 0xe. I need to rename. So these are not PSRL, these are PSRA. PSRAD, PSRAQ, PSRAQ, undefined. Oh yeah, this one didn't have the legacy version for this. Okay, so we've still got a problem here. Looks like we've got 7.3 when we should be getting 7.2, for example. So basically outputting a 3 here instead of a 2. Prefix 6. This is E1. Okay, so E1 is okay there. We've got the opcode map correct. We've got the correct prefix. Oh, this is just for Q. Okay, let's go to Q. So the evex, is this evex? Yeah, we want evex. So for RAQ evex, we've got W1, but we're getting, this is because they don't support, so this RAQ one is actually a bit wrong then. So we've got encoder ASM, PSRAQ. So for RAQ, do they actually have a VEX version of these? No, there is no VEX version. They're only EVEX, so I may as well just remove these tests here. And we'll just reassemble that. And then we'll remove the RAQ VEX encodings. Okay, so now we're getting failures on these ones instead. Do these ones support broadcast? Yes, they do support broadcast with the immediate versions. So we've got W1 for these. W1 is set. We have E2, 7.2, and opcode extension 4. Opcode extension is 4 with 7.2. That one's D. This should be if the opcode extension is 4, then it should be 7.2 here. And then for this one, okay, so this one's the top encoding here. Let's just go and have a look at that one. So that is 660F E2. This is E3, so this should be E2. Okay, so that's all of the shifting left and right for packed. But there's also variable versions of these down here. So we've got VPSLL, VW, D, and Q. And these ones only have RVM operand encodings. So we got RVM here anyway. Let's just go and have a look and make sure. So these ones, D and Q, support memory broadcast. In all cases, it looks like they support memory access as well. So let's just write these ones out fresh. So we've got W, D, and Q for this. So this one's D. Where's W? W is down here. So we've got so basically, W doesn't have a VEX encoding. So it's only D and Q for VEX encoding here. W only starts with the EVEX. Okay, let's go to the encoder tests again. So basically, this time we've got VPSR. Well, let's do SLL VW. So this is the variable bit shift. So VPSLL VW, VPSLL VW. Okay. So this is RVM for all of them. So we'll do XMEM0, XMEM1, XMM2. And then we'll do the memory access here. So this is actually VEX, so this should be D. Then we've got YMM for this, because the VEX supports, for D it's got XMM and YMM, same goes for Q. Actually, let's just do which one should I do first? Would just stick with doing you know, grouping them by suffix. So we'll do D here. Then we've got the D version for EVEX is the same. It has opcode masks and it has broadcasts. So in this case, we'll do the opcode masks. Why don't we just do K3 here, just to make it a bit different. Then we also need broadcasts. So this one is going to be 1 to 4. This one will also be 1 to 4. And then we need one for ZMM. So that takes care of the D version. We'll also need the W version, which I'll put before this, but this doesn't have a VEX encoding. So this one should be W here. And this one, because it's W, I assume doesn't support the broadcasts. So we'll remove the broadcasts from these ones. And then we can make a copy of this one for Q, which should be the same. So this will be VQ. And there is no DQ version of these. So let's just run NASM. So we've got a mismatch in the number of so Q, it has doubled, so we need to halve the lanes. So this is 2. Oh, this is also a mismatch here. So we've got, this should be to 8, this should be to 16, this one should be to 2, this one should be to 4, this one should be to 8. Okay, that looks like it's okay. So I think we can just take a copy of these. I think the other ones are basically the same. So we'll just change LL to, let's do, well, I suppose it doesn't matter. We'll do LL and then RA. And then we'll take one more copy. And instead of RA, this will be RL. So I think that covers all of them. Let's just see if it assembles okay. Yep, okay, let's just put the test notation in. Align them all. Reassemble. Okay, so go test should fail. So we've got a failure on VW as the first ones. So let's just go and take all of these all of these variable form mnemonics over to the mnemonics file first. So let's just go to mnemonic. I suppose we may as well put them into the name table since I'm already on it. We'll get rid of any duplicates. We'll separate these by LL, RA, and RL. Put the names here. Okay, let's just copy these up to the constants. And then we'll go and put them in the forms. So these will be empty form tables. Let's just go and test that. That is all okay. So now we just need the forms. So VPSLLVW is actually starting with only EVEX here. So we'll just do family is EVEX. Op-N for this is always op-N RVM. So op1 is VEC, op2 is always a VEC, and then op3 can be VEC or memory. So this one has a prefix of 66. Yeah, prefix 66, map is 38. And then the opcode here is, so we've got EVEX for W, opcode is 12, and for this one, W is actually set. So we're still getting, yeah, op1 needs to accept op mask, and it needs to accept zeroing. So we're still getting some incorrect, we still can't match with VPSLLW. So we've got EVEX, we've got RVM, we've got VEC, VEC or memory. We've got op mask and zeroing. So why can't this match? VEC. VEC. That should be, oh, this needs to match on, I forgot to put the width. So width should be, for this one, we've got EVEX with XMEM, YMM, and ZMM. So this is X word, Y word, and Z word. Okay, let's try that again. Okay, so now we're on to the D version. So the D version has EVEX, but it also has VEX. So for the VEX version, we've got W is 0. So we'll just remove W from here. The opcode is 47. Yeah, okay, opcode is 47, but other than that, it's the same. And then for the EVEX version here, we've got 47 as well, but W is also not on here. And then this is basically the same for the Q version, but in this case, the W bit is set. Okay, so VPSLLVD. So this is still not matching. This one supports broadcast. Okay, so that means that these ones also support broadcast for the EVEX versions. Okay, so now we're on to the RA instructions. So I'll just copy these. We'll rename LL to RA. And with RA, we've got 4, 6, and 1, 1. So this is 4, 6. Let's just test that. So we want EVEX in this case. We're getting VEX. So RAVQ only has VEX for the D version. So this D version has VEX. The Q version should not have VEX at all. Okay, so now we're on to PSRL. This one has VEX for D and Q, so we'll just copy the first forms again and take them down to here, and we'll rename LL to RL. And these ones use 4, 5 for both of these, and 1, 0 for W. So W is using 1, 0, and then these are using 4, 5 instead of 4, 7. Okay, so that was shifting for packed data.